The shape of flight. Understanding airfoils. Airfoils are the key to flight. They are the specially shaped surfaces like wings and propeller blades that generate lift. The shape of an airfoil is crucial. Think of a wing sliced in half lengthwise. The top is curved and the bottom is relatively flat. This asymmetry is what makes airfoils work. When air flows over this shape, something fascinating happens. The curved top surface forces the air to travel a longer distance than the air flowing under the wing. This difference in distance creates a difference in air pressure. This pressure difference is what generates lift. Bernoulli's principle: faster air, lower pressure. Daniel Bernoulli, a Swiss mathematician, discovered a principle that helps explain lift. Bernoulli's principle states that faster moving air creates lower pressure. Remember the airfoil shape? The air traveling over the top of the wing has to move faster to keep up with the air flowing underneath. This faster moving air creates lower pressure above the wing. Meanwhile, the slower moving air below the wing exerts higher pressure. This pressure difference, high pressure below and low pressure above, pushes the wing upwards, generating lift. Newton's third law. Every action has a reaction. This fundamental principle of physics, articulated by Sir Isaac Newton, is a cornerstone in understanding the mechanics of flight. It is not just a theoretical concept, but a practical one that we see in action every time an aircraft takes to the skies. Sir Isaac Newton's third law of motion also plays a crucial role in lift, which is one of the four fundamental forces of flight. Lift is what allows an aircraft to rise off the ground and stay in the air. Without lift, powered flight would be impossible. This law states that for every action, there is an equal and opposite reaction. This means that any force exerted on a body will result in a force of equal magnitude but in the opposite direction. This principle is essential in explaining how wings generate lift. As the wing deflects air downwards, the air pushes back on the wing with an equal force but in the opposite direction, upwards. This upward force is what we call lift. The design of the wing, or airfoil, is crucial in maximizing this effect. This downward deflection of air is called downwash. Downwash is a critical component in the creation of lift. When the wing pushes the air down, the reaction force pushes the wing up, helping the aircraft to ascend. It's important to remember that lift isn't solely created by the air hitting the bottom of the wing. The shape of the wing also plays a significant role. The curved upper surface of the wing causes the air to move faster over the top than underneath, creating a pressure difference. The combination of downwash and the pressure difference from Bernoulli's principle contribute to the overall lift generated by an airfoil. Bernoulli's principle states that an increase in the speed of a fluid occurs simultaneously with a decrease in pressure. This principle, along with Newton's third law, helps us understand the complex interactions that allow an aircraft to fly. Pilots rely on their understanding of these principles to control the aircraft. By adjusting the angle of attack and the speed, they can manipulate the forces of lift and drag to achieve stable flight. Every maneuver, from takeoff to landing, is a practical application of these fundamental laws of physics. Understanding the science behind flight not only enhances our appreciation of aviation, but also underscores the incredible ingenuity and precision required to design and operate aircraft. Every action taken by the pilot and every design element of the aircraft work together in harmony, governed by the unyielding laws of physics. The angle of attack. Finding the lift sweet spot. The angle of attack is another critical factor in generating lift. It plays a pivotal role in determining how efficiently an aircraft can fly. By understanding and manipulating the angle of attack, pilots can optimize the performance of their aircraft, ensuring both safety and efficiency. It's the angle between the chord line of the airfoil, an imaginary line from the leading edge to the trailing edge, and the direction of the oncoming airflow. This angle is crucial because it directly affects the amount of lift generated by the wing. A small change in the angle of attack can have a significant impact on the aircraft's performance. Increasing the angle of attack increases lift, to a point. As the angle of attack increases, the lift generated by the wing also increases, allowing the aircraft to climb and maintain altitude. However, this relationship is not linear and has its limits. There's a limit to how much the angle of attack can be increased before the airflow becomes disrupted, and the wing stalls. When the angle of attack becomes too high, the smooth flow of air over the wing is interrupted, leading to a dramatic loss of lift. A stall occurs when the airflow separates from the upper surface of the wing, resulting in a sudden loss of lift. This can be a dangerous situation, as the aircraft may lose altitude rapidly. Pilots must be aware of the signs of an impending stall and take corrective action to prevent it. Pilots are trained to recognize and avoid stalls. They undergo rigorous training in simulators and real aircraft to practice stall recovery techniques. This training ensures that they can handle such situations effectively, maintaining control of the aircraft and ensuring the safety of everyone on board. Understanding the angle of attack and its implications is a fundamental aspect of a pilot's education and is crucial for safe flight operations. Section 5. Airfoil designs, different wings for different flights. Not all airfoils are created equal. Different airfoil designs are optimized for different flight characteristics. For example, a thick airfoil with a highly curved upper surface might be used for low-speed flight, like that of a glider. A thin airfoil with a less pronounced curve might be found on a high-speed aircraft. Factors like wingspan, wing area, and the use of flaps and slats also influence lift and aircraft performance. Understanding these design variations helps engineers and pilots optimize aircraft for their intended purposes. Section 6. Takeoff and landing lift in action. Lift is crucial during takeoff and landing. To take off, an aircraft needs to generate enough lift to overcome its weight. Pilots increase the engine power, which increases the airflow over the wings, generating more lift. During landing, pilots reduce engine power and adjust the angle of attack to decrease lift gradually. This controlled decrease in lift allows for a smooth and controlled descent. Section 7. Debunking lift myths. Separating fact from fiction. There are many misconceptions about how lift works. These misconceptions often stem from oversimplified explanations or outdated theories that have been passed down through generations. Understanding the true mechanics of lift is crucial not only for aviation enthusiasts but also for anyone interested in the science of flight. By debunking these myths, we can gain a clearer and more accurate picture of how airplanes stay in the sky. One common myth is that lift is solely generated by air hitting the bottom of the wing. This idea suggests that the force of the air pushing up against the wing is what keeps the plane aloft. While it's true that the pressure difference between the top and bottom of the wing contributes to lift, this explanation is far too simplistic and doesn't account for the complex interactions of airflow around the wing. As we've discussed, Bernoulli's principle and downwash play significant roles. Bernoulli's principle explains how the faster airflow over the curved top surface of the wing creates a lower pressure area, contributing to lift. Downwash, on the other hand, refers to the downward deflection of air as it leaves the trailing edge of the wing, which also helps generate lift. These principles work together to create the lift needed for flight. Another myth is that planes fly because of equal transit time. The idea that air molecules separated at the leading edge of the wing must meet up simultaneously at the trailing edge. This theory suggests that the difference in pressure above and below the wing is due to the air traveling different distances in the same amount of time. However, this is not accurate and oversimplifies the true nature of airflow around the wing. This is not true. The air traveling over the top of the wing actually moves much faster. The faster moving air over the top surface of the wing creates a lower pressure area, which, combined with the higher pressure on the bottom surface, generates lift. This difference in airspeed and pressure is a key factor in understanding how lift is produced. Understanding the true principles of lift is essential for anyone interested in aviation. By dispelling these myths and focusing on the accurate science behind flight, we can appreciate the incredible engineering and physics that allow airplanes to soar through the skies. Whether you're a student, a pilot, or simply curious about how things work, grasping these concepts will deepen your appreciation for the marvel of flight. Section 8. Lift, the key to aviation. Lift is the fundamental force that makes flight possible. From the Wright brothers' first flight to modern jetliners, the principles of lift have enabled us to conquer the skies. Understanding how airfoils, Bernoulli's principle, Newton's third law, and the angle of attack all work together to generate lift is essential for pilots, engineers, and anyone fascinated by the science of flight. As we continue to push the boundaries of aviation technology, our understanding of lift will continue to shape the future of air travel. Section 9. Conclusion. Soaring on the principles of flight. The next time you watch an airplane soar through the sky, take a moment to appreciate the invisible forces at work. Lift, generated by the ingenious interplay of airfoils and aerodynamic principles, is a testament to human ingenuity and our relentless pursuit of exploring the world around us. By understanding the fundamental principles of lift, we gain a deeper appreciation for the science that allows us to defy gravity and experience the wonder of flight.